Okay, hello everyone. So today we are going to the previous year question of the permutation and combination. Correct? I hope it's clear for everybody. Okay, hello everyone. So today Okay, so we will start with the first question from all the English alphabet. Okay, so we will start with the first question from all the English alphabet. Correct. Okay, so we will start with the first question, and the question is from all the English alphabet, 5 letters chosen and are arranged in alphabetical order. The total number of ways in which the middle letter is M, right? So we have to see that 5 letters we are choosing and we are arranging in the alphabetical order, right? And the total number of ways we have to find in which the middle letter is always M, right? So the middle letter M is to be fixed. Middle letter M is to be fixed. So what I will do, I will fix the M first. M I will fix, and 5 letters are there, and since it is alphabetical order, right? So 2 letters I am taking here, 2 letters I am taking here. Now what comes before M, right? What comes before M? That is what A to L. A to L will come before M, and from here it will come N to Z, correct? This is fixed, M to N. Now A to L is how many letters? A to L is how many letters? 12. Out of that 12, we have to choose 2. So this will become 12C2. And then from N to Z, obviously this will be the 13th, and then 13 will be here. And out of these 13, I have to choose again 2. So this will become 12C2 and 13C2. Now easy, we will try to solve it. 12C2 we know NCR is what? N factorial, N minus R and R factorial. So this will become 12 factorial, 12 minus 2 here it will be 10 factorial, and this will become 2 factorial. Here it will become 13 factorial, 13 minus 2, 11 factorial and 2 factorial, correct? This will cancel 10 to, this will become 11 into 12, and this will become 2 multiplied by 12 into 13, and this will become 2 here, correct? Simple calculation we will do. This will 6, this is 6, 66 into 13 6 is 78, right? Just multiply it, and okay, let me multiply 78 and 2 66, 6 6 are 48, and 6 8 6 and 4. This will give 8 6. Then 1 5. Okay, so the final answer will come as 5148, and that is our option number D. That is our option number D. Okay, now we'll move to next question. Now let's see what the next question is. Question number 2 I will be moving, and that is also from permutation and combination. Okay, so I'm writing down the next question. Okay, just see the next question. The next question says, let A, okay, A is some set given, and this is from 1 to 10, 1, 2, 3, 4 and so on till 10. And B is some set given, B is some set given, but B is not given directly. B they have given in the form of M by N, and in which the condition, some condition is given, M upon N belongs to A. Okay, so the element we have to take it from, A only, right? M and N belongs to M, A, and GC, that is the greatest common divisor of M comma N is equal to 1. Okay, so whatever element we are choosing now, we have to take care for this thing, that the greatest common divisor of M upon N, that should be equal to 1, right? Okay, next is the number of element in B. the number of element in B is equal to, and the options given are, what are the options given? 31, 36, 31, 36, 31, 36, 37 and 29. Okay, so this is the question. Now see how we can proceed. First of all, m upon n. Now, so try to fix something. Try to fix something. And already given one condition. Okay, I think I have missed one condition, that m is less than n. One condition is m is less than n. Okay, so one more condition is given, that m is less than n. Okay, so the numerator is always lesser than the denominator part, right? Now just see how we can proceed. So if I try to fix n is equal to 1, obviously that will not make any sense, because n is equal to 1, it will not make any sense. Reason is, in that case I cannot choose m any element, because even if I take 1, 1 upon 1 will not work, right? So I have to start with n, right? So if I choose n is equal to 2, now what are the condition I can fix here? 1 upon 2 is the condition, right? So first condition I will fix is 1 upon 2. Okay. Is it okay? Is it okay, right? Now next case I will take n is equal to 3. If I take n is equal to 3, then I can write 1 upon 3 and 2 upon 3. Obviously 3 upon 3 we cannot write, because the greatest common divisor is 1, right? Both. So for n is equal to 4, n is equal to 4, we will continue with n is equal to 4, and n is equal to 4 I can write 1 upon 4, 2 upon 4 obviously we cannot write, 3 upon 4, and then 4 upon 4, no, 4 upon 4 is also not possible, right? So this is n is equal to 4. Then n is equal to 5. So 1 upon 5 is possible. Just take care of this property, that m should be less than n, and the greatest common divisor is equal to 1 only, right? So this is the case. N is equal to, this will become 2 upon 5, 3 upon 5. Is it possible? 4 upon 5, right? So how many cases here? 4 cases here, right? Similarly continue. N is equal to 6. I can write 1 upon 6. 2 upon 6 is not possible. 3 upon 6 is not possible. 4 upon 6 is also, 4 upon 6 is not possible. And 5 upon 6. So from here I am getting 1 upon 6, 2 upon 6. It is not possible. So I am writing here. Then come to n is equal to 7. Then 1 upon 7 is also possible. I think everything will be possible since 7 is prime, no? So 2 upon 7 is possible, 3 upon 7 is possible, 4 upon 7 is possible, 5 upon 7 is possible, 6 upon 7, and we'll stop. Now come to the last cases. 1 upon 8 is possible, 2 upon 8 not possible, 3 upon 8 possible, 5 upon 8 possible, 7 upon 8 possible, and stop here. Correct? Then n is equal to 9. We can go till 10, no? Yes, we can go till 10. This 1 upon 9, 2 upon 9, 3 upon 9 is not possible, so 4 upon 9, 5 upon 9, 7 upon 9, and 8 upon 9. And the final, n is equal to 10. Right? Why we are doing? Just to add how many numbers of element we have. So just to add that how many elements we are formed, and then finally we will count. Finally we will make a count. This is 1 upon 10, 2 upon 10 is obviously not possible, so 3 upon 10, 4 upon 10 not possible, 5 upon 10 not possible, 6 not possible, 7 is possible, 8 is not possible, and then finally 10 is possible, 9 upon 10 is, right? So now count it, make a simple count. Here it is 4, 7, 10, 14, 17, 20, 22, 24, 26, 28, 29, right? Are we missing something? Just check. Cross verify anything we are missing. No, it is 31. The count is 31, right? So 31 is the total count, and we have the final answer as 31 only, right? So we are not missing anything. So 31 will be the number of element in the set B. I hope this is clear for you, right? Can we move to the next one? Yes. I am moving to the next one, question number 3. That is again from the permutation and combination. I hope it is clear for everybody. Okay. Now question number 3, writing. Just see what is the question number 3. Okay, so I'm writing down the question number third. In a group of three girls, in a group of three girls and four boys, there are two boys B1 and B2. There are two boys B1 and B2. The number of ways in which these girls and boys can stand in a queue, such that all girls stand together. Now the condition starts, such that all girls stand together, right? So this is the condition. I am marking this condition so that while solving this problem now, such that all the girls stand together. And next is what? But B1 and B2 are not adjacent to each other. Okay, so there is a problem with B1 and B2 also. They should not adjacent to, are not, I am marking the word not adjacent to each other. Okay, so the problem is what? B1 and B2 stand anywhere but not adjacent with each other, right? So now see, instead of finding that what are the conditions in which B1 and B2 cannot stand together, what we can do? We can find the total condition minus in which the B1 and B2 are standing together, correct? Means we are finding the ways in which total ways minus all those ways in which B1 and B2 are together, correct? Okay, so just see what are the total ways we have. Just see the total. How many girls are there? 3 girls are there, no? So 3 girls and 4 boys. So obviously, let's suppose I am writing the girl just for a pictorial representation. G1, G2, G3, correct? And I am representing the boys as B1, B2, B3 and B4. I am taking the total situation, right? Total cases. So what are the total cases? These G1, G2, G3 girls can stand in how many ways? The number of ways is 3 factorial, correct? No problem. Then B1, B2, B3, 4, B4, they can stand in how many ways? They can stand in 4 ways, 4 factorial ways, correct? No problem. Now there is one more way, that all the boys can come forward and all the girls can go backward. That is also one case, no? So that case I am 2 factorial, correct? Now this is the total ways where there is no restriction. That is the total case where there is no restriction. Now come to the restriction part, that I want B1 and B2 together. So if B1 and B2 are together, if B1, because they have asked not, no, so total minus the condition where B1 and B2 are standing together, right? So that will give you the not condition, correct? So if B1 and B2 are standing together, now this we will consider as one. B1 and B2 we will not consider separately. So now it becomes 1, 2, 3 only, right? So now this arrangement can be done in 3 factorial ways. Girls obviously can come into 3 factorial ways. Now this again, all the boys can come forward, all the girls can go backward. So that is one kind of representation, that is 2 factorial. Then, but there is one more thing, that B1 and B2 can internally rearrange themselves. No, B1 can ask B2, you can come backward, I can go forward. So that is also 2 factorial. Correct? Now do the simple calculation. Okay, so calculation we can do is, we can take common what? 2 factorial, 3 factorial we can take common. Any other thing we can take common? No. Okay, so here I will left with 4 factorial minus 3 factorial into 2 factorial, right? What is the 2 factorial? 2 factorial nothing but 2, 3 factorial is 6, and this will become how much? 4 factorial is 24 minus 6 into 2, right? So how much this is? 12, 24 minus 12. This will come 12 and 24 minus, okay, so this is 12. So 144. This was the total part. This was the ways in which B1 and B2 is together. So that will give you the not condition, right? That will give you the not condition. So I think it is clear for everybody. So okay, I have not written the option. So finally I am writing the answer. Will be what? 144. The answer will be what? 144. I can move to the next part, right? I can move to the next question. Okay, I am writing down the next question. Question number, this will be 4, right? Question number 4. Now I am writing down the next question, that is question number 4. Okay, just see what is the question number 4. The number of words that can be formed using the letters of the word, using the letters of word daughter, DAUGHTER. Okay, using the letters of the word. So word that is given is daughter. The word that is given is daughter, and so the vowels never come together. Okay, so again one condition, so that all the vowels never together, right? So the condition is what? All the word vowels never come together. Now see the condition. So options are given as 34,000, B option is given as 37,000, C option is given as 36,000, D option is given as 35,000, right? 35,000. Now just see. Okay, so in the previous question what we did, we subtracted the total condition minus where the condition was favorable. Again they have asked, we have used the word never come together, right? So we will take the condition, total condition minus where it comes together. So that will obviously give what? Never comes together. Comes together, right? Where the vowels are together, or better, right? Vowels come together. Where the vowels come together, correct? Now just see, what is the total condition we have? So how many? Find the letters DAU 4 and 4 8. Okay. So how many letters we have is in daughter we have. I am writing it again. DAUGHTER. Okay. And what are the vowels? This is the first vowel. This is the second vowel, and this. Okay. So third. So 3 vowels are there, right? So first thing is what? Total condition is what? Total condition is 8 factorial. Correct. How many ways we can rearrange it? 8 factorial ways. And let's suppose the vowels are together. If the vowels are together, this could be 3 factorial. 3 factorial, these 3, and this will be, okay, do like this. This 3 as 1. Take this 3 as 1. Then this will become 6. 1, 2, 3, 4, 5. This will become 6 factorial. Right? D is 1, G is second, H is third, T is fourth, and R is fifth. And I am considering it A, U, and E as 1 because I am taking at vowels come together. So this will obviously become 6 now. 6 factorial. Now internal rearrangement of A, U, E is possible. Internal rearrangement of A, U is possible. So I will write it as what? 3 factorial. I will write it as 3 factorial, right? I will write it as 3 factorial. Now just see the condition. how much it will, so I can take here common what, 6 factorial. If I take 6 factorial, this will be left with 7 multiplied by 8, that is nothing but 56. And if I take here 3 factorial, so nothing but 6, right? So the calculation will become easy. 6 factorial is how much? 720, and this will become what, 50. Now 72 into 5 is 360, and how many zeros are left? 00. Okay, so the final answer will come as 36,000. So final answer is 36,000. Option number C is correct. I can move to the next one. Just see what is the next question. Just find it from the permutation and combination. Okay, the next question we have is, the next question we have, okay, I am writing down the next question. This will be the question number 5 from the permutation combination. Just see what the question says. Question number 5. A board has 16 square. Okay, a board has 16 squares shown in the figure. Okay, so the figure is also given, shown in the figure. Okay, so there is some kind of board which has 16 square. I am making it a square. Okay, this will be, okay, this is a rough one. Okay, okay, out of this 16, out of this 16, 2 square are chosen at random. 2 square chosen at random. 2 square chosen at random. Okay, how many square they are choosing? 2. Okay, the probability, okay, this comes under the probability as well. No problem. The probability